What we're going to do is look at Venn diagrams. This is another type of probability diagram. With Venn diagrams, all Venn diagrams are going to add up to 1 because 1 means every possible event. So whenever we add up all the probabilities, it should always equal 1. Also, whenever we're setting up a Venn diagram, we always start with the middle. If there is a middle, we always start with that probability first. Now, there's 3 different types. First one we're going to look at is a disjoint probability. Another word would be mutually exclusive. And what that means is that 2 events have nothing in common. So we have event A, we have event B, and event A and B have nothing in common. So what we're going to do is we're going to fill in our probabilities. So the probability of A is 0.4, the probability of B is 0.5, and outside of it has to be 0.1 because all of these probabilities have to add up to 1. So the C means complement or not A. So not A would include the 0.5 and the 0.1, which would be 0.6. The A and B, notice that they have nothing in common. So since they have nothing in common, then that means that it would be 0. Or means we add up all the probabilities. So we're adding up the 0.4 and the 0.5, which is 0.9. Now, the line right here means given. It's a conditional probability, and what it means is a fraction. We put B on the bottom, and so if B is on the bottom, that would be 0.5. Given that 0.5 happens, what's the probability that A happens? Well, there's no A in 0.5, so that would be 0, meaning that our probability is 0. Now, the second type is a dependent probability. Dependent probabilities never say it. So if we have a Venn diagram and there's nothing said, then we know that it's dependent. And what we have is A, and then we have event B. And we're going to start off with the middle, which in this case is 0.1. Now, this is where it gets a little tricky. If event A is 0.4, notice that A already has the 0.1 in it, so this is going to be 0.3. For probability of B, that would be 0.5, but there's already a 0.1 there, so this would be 0.4. And all the probabilities add up to 1, so this on the outside would be 0.2. Now, what we're going to find is not A and B. So what I like to do is draw lines to help me with this. So not A would include the 0.4 and the 0.2. And the B would include, let's pick a different color. No, let's actually use a highlighter. The B would include the 0.1 and the 0.4. Now, since this is an and statement, we see where that's overlapping. So overlapping would be where there's a highlighter red, and where there's a highlighter red would be 0.4. Now, once again, this symbol right here means and, or where they intersect. This symbol right here means or what they have all together, and we're going to be adding those probabilities. So looking at the next one, what we're going to do is we're going to clear out the marks, and we're going to fill in. And we're going to do this again. So what we have is A would include the 0.3 and the 0.1, and not B would include the 0.3 and the 0.2, or means where what we have all together, which would be the 0.3, 0.1, and 0.2, which would be the 0.6. For letter C, this is a conditional probability. So the given part is B. Think of it as a fraction. We put B on the bottom, so that would be 0.5. B includes the whole circle of B. Now, of the 2 circles of B, we have the 0.1 and we have the 0.4. Now, of those two possibilities, which one is A? And the only one that's A is the 0.1, so that would be 1/5. Same thing, B given A. So what we're going to do is we're first going to put our denominator as A. A would include the 0.4, the 0.3, and the 0.1. Now, of those two, which one is B? And the answer is 0.1. So it's 1/4. Now, example 3, this right here is independent. Independent means that the middle is the product of the two. So notice they don't give us a middle, because what we're going to be doing is we're going to be finding the product 0.7 and 0.3, which is 0.21. Now that means that only A would be 0.49 because it adds up to 0.7, and only B would be 0.09, and then on the outside it would be 0.21. So the first thing I'm going to do is not A. Let's define A and B. So not A would be the 0.09 and the 0.21. And then the B would include the 0.21 and the 0.09. Now, and statements are where they overlap. So where does the purple and the blue overlap? That would be 0.09. Now, if we're looking at the next one, let's look at A. A would be the 0.49 and the 0.21. Not B. Not B would include the 0.49 and the 0.21. But since this is an or statement means where we add up wherever there's a line, and that would be 0.91. Now, letter C, this is a conditional probability. Think of a fraction. We're going to put not B on the bottom. So when we're looking at not B, what we're doing is we're looking at everything that is not B. So that would include the 0.49 and the 0.21. So not B would be 0.7. Now, of those two options, which one is the A? And of course, it would be the 0.49. So that would be 49/70. And then for the next one, what we have is we have the given part is the B. So we put B as our denominator. B would include the 0.3, 0.21, and the 0.09. Of those two options, which one is not A? And not A would be the 0.09. So that right there would be 9/30. Now for example 4, this time we have a word problem. And with the word problem, we have to create our own Venn diagram. And we have two different events. This would be Mr. Nichols gets coffee to grade the stats test. The probability that he uses a gift card, so gift card would be 0.88. The probability that he uses cash, cash would be 15%. And the probability he uses cash and a gift card would be 8%. So we're going to start off with the 0.08, which is in the middle. We always start in the middle. That means using a gift card would be 0.80 because those two have to add up to 88%. And only cash would be 0.07 because those two have to add up to 15%. And if we were to add all of these up, what we would have is 0.05 on the bottom because all of those probabilities have to add up to 1. Now, what is the probability that Mr. Nichols pays only cash? Only cash would be the 0.07 because it's cash and nothing else. What is the probability that Mr. Nichols has some other method than a gift card or cash? That would be the number on the outside, which is 0.05. What is the probability that Mr. Nichols uses his gift card given that he is paying in cash? So we know that Mr. Nichols is paying in cash. That would be one of those two probabilities. So in our denominator, what we would have is 0.15. Now, of those two possibilities, so what is the probability Mr. Nichols uses his gift card? So of those two, the 0.08 would be the gift card. And so that would be 8/15.